Patel, you're right over here. He was nominated by Mahantosh. Chandrakant is one of 4 Hewlett-Packard senior fellows and currently is the chief engineer of HP Laboratories. In 1990, Chandrakant foresaw the need to reduce available energy consumption by dynamically provisioning, if you will, sorry, should have gone to school on that one, IT power and water cooling resources in the data center. It led to the development and the end-to-end management of systems to address energy consumption and the total cost of ownership. Chandrakant passionately shares his work by teaching in community colleges. He is an ASME and an IEEE fellow. He has been granted 126 U.S. patents and has published more than 150 papers. In recognition for his work in the community, he was profiled by ABC, KGO here in television, in the Emmy Award-winning series Profiles of Excellence, and it was for his contributions to science, technology, and education. Ladies and gentlemen, Chandrakant.
I'm an extemporaneous speaker, but today I brought notes. Thank you, Stanley. And a very good evening to every one of you. In the next 5 minutes, I will narrate a journey that has been shaped by observations. But before I begin, I must say thank you to Silicon Valley Engineering Council, to Stan Myers, the awards committee, and my nominators, Dr. Haddad and Dr. Hirmat. I am humbled and honored by this recognition. I would not be standing here if it were not for my managers, my mentors, my coach, and my colleagues at HP. I thank them for their selfless collaboration. Outside of HP, I have had a great fortune of having an awesome group of friends who have provided great support and guidance. And I have had great students from whom I have drawn great inspiration. And as a mentor, I have been very happy. It's brought me great joy to see them very successful in companies like Google and going on to finish their PhDs. And these were students in community college who most had written off. And I'm a big proponent and an advocate of community college system. I am a product of City College of San Francisco, and I'm proud of that. The foundation of my support has been my family. My wife of 3 decades has been the greatest contributor. She has coached and mentored myself and my 3 hardworking children. I am here as an engineer because my father taught me drawing and sketching. A graduate of University of Illinois Urbana-Champaign, he built this nation's infrastructure, the suspension bridges over Mississippi, and I was greatly inspired by it. But I dedicate my award to my mother. She lived in a village under torturous circumstances in the 50s so that my father could leave the village and study for 8 years, and she never complained. Had she not made those sacrifices, I wouldn't be standing here and we would not have been that fortunate. She's not with us. I dedicate this to my mother. as I look back, this has been a journey that has been shaped by observations. As a child growing up in India, my interactions with my pen pals back in the day with physical mail, from my early days to my high school days, I found out that my pen pals in the US, they worked on their father's cars. They delivered newspaper, they mowed lawns, and they saved money to build radio-controlled planes. America was a land of tinkerers. Furthermore, America was steeped in fundamentals. My friends carried Resnick and Holiday, Sears and Jimansky, the Western edition. And they not only understood the fundamentals from Sears and Jimansky, Resnick and Holiday, they had the resources to ground themselves given the fundamentals. By contrast, in India, we were lucky we could share one copy of Holiday and Resnick with all the friends, and we had no access to radio-controlled planes. We built gliders. When I came to US and started in Silicon Valley, I found myself in a valley of tinkerers. But I came here in the 80s. And tinkerers were Bill Hewlett, who actually visited us and spent time at the workbench in the Tinker Tank. That was what our lab was called. Bill Hewlett, Dave Packard, Robert Noyce, Gordon Moore, to name a few. These tinkerers created the fundamental discoveries that powers the Silicon Valley today. Over the period of next 30 years, we put layers of abstraction that hid the complexity. But that abstraction was great. It gave us the internet and gave us the awesome systemic innovations we see on the internet. But as we look ahead, we must go back and create new fundamental discovery that will power the Silicon Valley for the next 50 years. And we must use the internet for systemic innovation, innovations that will be used to manage our power, water, waste, transport, and improve productivity and reduce natural resource consumption. So, in the future, we will be developing apps to manage our water system. We will need to know how a pump is built, and we need to know how our supply side infrastructure was built by our ancestors. My wife will tell you, we do supply side walks. Recently we were at Lake Chabot to see how our ancestors, 800 workers, built the reservoir that provides water in San Leandro, Oakland area. So as we look ahead, in order to address this world where we must create new fundamental discoveries and do systemic innovations, we must build a cadre of contributors who are akin to the pen pals that I had of yesteryear. So in high school, our children must find it cool to carry Resnick and Holiday, Sears and Jimansky. Our students must learn metal shop, woodworking, get hands-on, and they must have passion for information technology and a passion to use information technology to address social, economical, and ecological concerns, to operate at the intersection of people, profit, and planet. This is the advice I have given my students and my son as well. My son did his undergraduate in the University of San Diego, bioengineering, master's in bioengineering, and is at medical school at Michigan State. When he was in high school, he came to me and said, "Dad, I'm going to take a computer class." And I told him, anybody can be a mouse jockey. Why don't you take metalworking and woodworking? Last summer, he worked with the Michigan State University Mechanical Engineering Department to build systems that can be used to do wound healing. So he was at the hospital, he was in the machine shop building things, and he said, "Dad, I'm so glad you told me to take machine shop." And by the way, when he went to the medical school, when he went to the hospital, he collected data, structured and unstructured data, which he analyzed using data analytics techniques to get insights to solve the problems. So here we are operating at the intersection of people, profit, planet, and metadata. So folks, as I look ahead, that is what I see. Our children, once again, steeped in fundamentals with hands-on training. And I see a future where we will once again create novel discoveries that will power us for 50 years. And I see an exciting future where we will leverage our past to operate at the intersection of people, profit, planet, and metadata. Thank you very much. And once again, I'm honored and humbled by this.